Recording in
Hands on everyone. Let's start off. Perfect. The number of people have decreased. Hope everyone has started giving your full syllabus advanced tests. Like I said, you are supposed to give at least 2 full syllabus tests every week. So yeah, in case you have not started, fix up 2 days in a week and make sure to give the full syllabus test. Unless you give tests, again, I'm telling you, once you start giving the test, trust me, first 6 or 7 tests you will mess up, and that is common. That is normal. So if you don't write tests, right, you won't get any feedback like, how much you have to improve and where you have to work. So start writing tests. I think maybe in the beginning, you might score 30, 40%, depending like how good you are so far. You might even score 50%. But from that is the point, your target should be all these mock tests. You need to aim for 65, 70% plus. So your job will be, okay, if I score 35% score today total, how do I take from 35 to 65? And you have 2 months to figure that out. And we can work on it. You're getting it. It is not like, oh, once you got 35%, you should start panic. It happens with everyone. And every year I see that. Normally, this time when kids write the exam, they score around 35%, 40% total score. But within 2 months, right, if you see every day you're doing only advanced, nothing else. Matlab, advanced level questions prepare kar rahe ho, advanced level papers likh rahe ho. So you actually get used to that level of difficulty. And what I have seen over a course of 2 months, right, the same kid who got 40%, by the time the May comes, right, their mocks the scores reach around 60 65%. That should be your number. If you ask me, sir, what should be the target? 70% score in your JEE advanced mock papers total score. That should be your aim, and this you will know only once you start writing papers. The more you delay to write papers, you are unnecessarily messing up your own preparation. Writing a paper is the fastest way to learn. 2 papers is minimum. If you can write 3, it will be awesome. And after writing the paper, just don't throw it away. Make sure to resolve the paper and get some good ones. And if possible, try to write 2020 to 2025, this 6 year papers, right, of JEE Advanced, instead of solving them like PYQs. It is preferable if you can solve them like exam papers. That will be great. Before 2020, you can solve all the PYQs. But at least in this, right, try to write these papers like an exam so that you will get an idea. Okay, if this is the exam I had given, how much I would have scored. Just to get an estimate, getting it. And let's say you wrote 2022 ka paper, and I don't know, I'm just putting some numbers, and let's say you scored some 55%, right? And again, don't treat it like exact score, okay? 55%, then matlab, this might have been 45% for you, decrease 10%. Because you're sitting at home comfortably, aram se, and by now you must have seen something similar like that. It happens every year, every JE paper, right? We teachers decode it, we create questions based on it, and we keep teaching you. So you guys will start feeling like, oh, paper itna easy hai. Once you go to the exam, the same paper looks like a monster. End of the day. So like I keep saying, last time also I told you, like, you have to keep solving one material. कुछ भी material, मतलब I told you LNGRS and FIT, just take their material, keep solving every day, जितना होगा इतना. It's not like you have to finish it off, like one sheet every day. Second thing, keep writing papers, minimum 2 papers. Again, when I said 2 papers, paper 1, paper 2, on one day, 9 to 5, 2 to 5, 9 to 12 and 2 to 5. हाँ, थोड़ा इधर उधर adjust कर सकते हो, मतलब, yeah. You want to start 8:30 to 11:30 or maybe 1:30 to 4:30, up to you. 50, half an hour, 1 hour, we can push it here and there. That is okay. But I'm telling you again, don't delay this. Think of like this entire March, whatever papers you write, ignore the score. Just write the papers. Mess up the papers, that is okay. You will get to learn a lot from it. April is the time you will improve. May is the final, that last 15 days is the time where you can actually see, okay, this is what I'm going to score. I'll also upload some papers today. I'll give you access to some 7-8 papers, right? But I'm sure your classes must have already started the test series, right? Your classes, or you must have enrolled in LN ka test series. Test series का problem ही नहीं है. Get something good and solid. right? So yeah, and I'll also, if you want, I'll get you some papers also of this LNK thing or FITGK papers. But getting papers is not a big deal. You also will get it. So make sure to write two papers. That is the thing. Okay, let's start off. So this, the point of percussion was the last thing that we did. Don't forget what I said. Take it seriously. Writing exams, it might feel exhausting and it feel like, oh, time waste or time waste nahi ho raha hai. When you solve the paper and if you mess it up also, and then when you resolve the paper, you're actually learning. And you'll actually learn better. In the last class, we did a lot of weird concepts. This is another thing, impulse-based problems. Let's say we got a ball of mass m projected with speed u at an angle theta. Coefficient of restitution E, friction is mu. The floor is rough. After collision, this angle becomes phi. Find the velocities and the ball constant is v. So find v and phi after collision. You must have done that question, where the floor was smooth, if you remember. If the floor was smooth, you can conserve horizontal momentum. Here, you can't do that. So just adding that a mu will make this from mains to suddenly an advanced level question. How do you handle this? Think. Just get me the equations. And after the equations, you have to say something. Think for 2 minutes, then I'll show you one and I'll ask you one more like this based on rotation. This is still a decent equation. I really won't say very tough. Yeah, but definitely more than means, but still easy level, easy to moderate in advance. How do you handle this? So let me help you with one. The problem here is right, is you can't conserve linear momentum, right? Vertical momentum is anyway gone. Energy also you can't conserve because the restitution is E is not equal to 1. There. So all conservations are out of the picture, right? And during the collision, how much time interval? We don't know the exactly time also. How much force will it exert? We don't know that also. So exactly writing in FBD also won't work. So if you see, right, in mechanics, we actually have mainly two categories: the force and the torque equations and the conservations. This is the third category. It's actually force only, but we don't directly write the forces as such. So this is how the picture will look. Listen to this thing because next problem is also based on this only. So when it hits the thing, what are the forces involved during the collision? So we have normal reaction, we have friction. These are impulsive forces. We can neglect mg because mg is very, very small compared to these two forces. These are impulsive forces. So non-impulsive forces can be neglected. What are non-impulsive? Impulsive forces are large forces. They act for short time during collision. So mg can be ignored. So this is the process during collision. After the collision gets over, let's say this thing gains velocity Vy and Vx. Now Vy is easy to find. That is nothing but E times U. Remember? If you hit a wall with speed U, you'll bounce back with EU. Only the velocity along the normal will become E times. Clear with that? That's a head-on collision. Vx is something which we don't know. So we are trying to find Vx. So if I find Vx, my job is done. So in the vertical direction, what are the forces acting? Normal reaction. So integral ndt, again, don't see the integral and get scared. Think of like this. Ndt is simply change in momentum. Is change in momentum in the vertical direction, which is nothing but 2 mvy, that is your final momentum, minus mu cos theta. That is your initial momentum. So yeah, so from here we will get integral ndt is equal to, sorry, this is also eu cos theta. My mistake. So that should be mu cos theta 1 plus e. That's your equation 1. Now in the horizontal direction, the only force acting is friction, which is acting backwards. So minus integral f dt is equal to change in horizontal momentum. The final momentum is mvx and the initial momentum is mu sine theta. Making sense? And here, since it is slipping, if you take this as f max, that will become minus integral mu ndt is equal to mvx minus mu sine theta. But what is ndt? So I don't know n, I don't know dt, but I know what is ndt. Take this guy and dump it here, and you'll end up with vx is equal to u cos theta mu 1 plus e with a minus sign plus u sine theta. That's your horizontal velocity. Once you know Vy and Vx, you can find angle, you can find speed and everything. Is this clear? But here, in impulse problems, there is always a small problem here. Now, after solving this, you always have to check if your Vx is greater than or equal to 0, right? Then my answer is right. Then Vx is equal to that u sine theta minus mu u cos theta 1 plus e. Fair enough. But if Vx is less than 0, what does it even mean? Think about it. If Vx is less than 0, you know what you're saying? The ball is thrown like this, it hits and bounces like this. Is that even possible? So what was the mistake we are doing? The mistake we are doing is you assumed, this f max acting for dt. So there is a possibility if Vx is less than 0, that implies, right, friction stopped acting somewhere in the middle of the collision. This implies slipping stopped. And friction stopped acting. F became 0. But you thought the friction was acting for the entire collision. I'll tell you what is the meaning of that. Listen, the scenario is this. Ask yourself, why is the friction even acting in the first place? The friction is acting because the ball is trying to go with Vx. So here, in order to avoid slipping, the friction was acting backward. Do you agree with this? For example, getting it, let's say, 10 milliseconds, or let's say 5 milliseconds is the total time of collision. I'm just putting some numbers for you to understand. Let's say 5 milliseconds is the total time of collision. Now, let's say your friction is so strong. This is the t is equal to 0 scenario, right? And maybe somewhere at t is equal to 2 milliseconds, the ball got deformed. The ball is deformed. And Vx became 0. Now you tell me, do you think friction will still act? The reason friction was acting because there was a Vx, so friction becomes 0 at this point, and the normal reaction is there. But the collision does not get over. The collision will continue till t is equal to 5 milliseconds. And then the ball will bounce back with Vy and Vx is 0. Is that making sense? So the equation actually becomes like this: integral minus f dt dash. Friction is maximum only, no doubt about it. But it will not be dt anymore, it will be dt dash, which is equal to delta px. Is that making sense? So that means if it is dt dash, then you cannot substitute ndt, right? So this method will not work. But we don't need actually. Why? If Vx is less than 0, that means slipping stopped and f becomes 0. What does this imply? Therefore, Vx is 0, right? Are you getting it? If the Vx becomes 0, friction stopped acting. That means the ball is not going to move horizontally. So this is what you do. You first solve the question normally, then you have to always check. If Vx is positive, your answer is right. If Vx is negative, then your answer is Vx is 0. Making sense? So you always have to check for those two conditions. So your final answer will look something like this. Vx will be u sine theta minus mu u e cos theta 1 plus c. You can actually put that, okay, you'll get tan theta is equal to mu by 1 plus c and all that. So this is the scenario if Vx is greater than equal to 0. If you got Vx is less than 0, that means the answer is 0. All clear with the process? So these are impulse-based questions. So this is the trap that you always have to check whether Vx is greater than 0 or not. So don't think this is the final answer. This is the final answer if Vx is still positive. Think about it. If Vx is positive means what? The friction was unable to stop you from slipping, right? The body is still slipping. Therefore, friction is acting for the entire duration of the collision. But during the collision, if the ball stopped, Vx became 0, why will the friction act in the during the collision? So friction will act for some time and then stops acting. So something like this. The total collision is so here your dt dash is your 2 milliseconds, and your dt is your 5 milliseconds. Clear with that? So these are some impulse-based questions. So let's see a better variation of this in rotation-based. This would be a solid advanced question. Even the previous one is a good one, but this is even better. Solid sphere, mass m, radius r. The ball is going with speed u, and the ball is also rotating with omega, and we have the floor here, mu and d. Same story. Find the final velocity and omega of the ball after collision. I can even ask you more questions. Find the position where the ball lands after collision. So in this scenario, right, this ball actually hits the floor and jumps like this projectile motion. You can bring projectile also into this, but yeah, if you got the velocity, you can get everything. So this is collision and rotation. So this is a much better one than the previous thing, but the idea is still the same. Get me the equations. So whenever you see these kind of questions, right, always you have to check for that no slipping condition. You'll get two answers. If it is slipping till the end, what you did was right. If it is stopped slipping in the middle, then yeah, friction vanished in the middle. Get this thing. I'll give 3 4 minutes. This is a good one. It could be a paragraph. Collisions, angular momentum, impulse based. Yeah. No, it is hitting the floor with u only. Ignore that height, and that u is the speed with which the ball hits the floor. So this is the speed just before collision. Clear, Arif? Hmm. Did everyone went through that IAR ka notes? You should have gone through that. Today I'll be teaching you a little higher version of IAR, matlab little different thing. Just get the equations. Don't Right. Let's see. Vy is the easy one. Hmm. Omega, okay. Hmm. Okay, let's see. I don't remember the answers, but same story. Always put a picture just for your understanding. So this is before collision. During collision, the forces are normal reaction, friction. That's it. We are ignoring mg. Just after collision, you have Vy, which is E times U. There is no doubt about it. This is Vx because it's a head-on collision. So that will be always EU. And this will be omega dash. So my main thing is to find Vx and omega dash, and my job's done. Perfect. Now there is one faster way to get a relation between Vx and omega. If you just take the point exactly below A, do you guys agree? Torque about A is zero. Because if you see during the collision, the only time the force was acting was during the collision. So N and F are acting about point A. Even mg is passing through point A. So torque about A is zero during the collision. Therefore, angular momentum is conserved about point A, which is A is a point on the floor. So L about A is constant. So initial angular momentum is equal to final angular momentum. Initial angular momentum of center of mass. Remember, this is a translation plus rotation, right? So angular momentum of center of mass, V is passing through A, so that is zero. Angular momentum about center of mass, I com omega, which is directions are important, minus k cap. L final, Vy will not have any angular momentum, but Vx will have angular momentum, which is MVxR. That is also minus k cap plus I com omega dash. This gives you one relation between Vx and omega dash. Then same thing, vertical impulse, integral ndt will give you mu1 plus e. This is the vertical momentum equation 2. And minus integral, sorry, f will be on the other side, because that omega r omega is rotating backward, it is pushing that way. So again, integral f max dt will be equal to mvx. You can take this and dump it here, and this will be mu into mu 1 plus e is equal to vx. Vx आ गया, dump it here, omega dash भी आ गया, everything is great. Make sense? In case by chance, angular momentum does not click, we can use angular impulse also. What is angular impulse? Angular impulse is integral f into r. This is the torque due to friction into dt. This should give you change. And we can write this thing as mu into r into integral dt.